All right, guys, I want to bring you into this Edpuzzle video after I've done this first problem. All right, that's because I don't want you to feel bad when you get something wrong. Right? I want you to know that even Mr. Field gets something wrong. So Nana has used a water purifier that filters 1/3 of the contaminants each hour. She used it to purify water that had 1/2 kilograms of contaminants. So we talked about exponential decay last week, and so this assignment is writing exponential decay functions. So we know that it's a b to the t, and b is the growth, but now we have to put slash decay factor, and then a is the initial value, right? So here's the thing. I got this wrong because I just put 1/3. All right. But 1/3 is being taken away. So we have to remember that we always start with 1. And then for this decay factor, it's going to be real important to subtract away the percentage decrease, or in this case, the amount decrease, in order to get the decay factor. In other words, the decay factor, you can write it down as 1 minus r. So we remember the growth factor was 1 plus r. This is 1 minus r. All right. So then that would make this 2/3. All right, so let's do another one to redeem myself here. Carbon 14 is an element that loses 10%, and a sample has 600. So right now I see the initial value is 600. Do you see that? And now they're not going to get me this time. It's losing 10% each time. So that means it's 1 minus 0.1, or simply 0.9. So losing 10% means it retains 90% each millennia, each time, whatever unit t is. All right, so that's writing exponential decay functions. Exponential functions from tables and graphs. That's the next one. The exponential function whose graph is given below can be written as g of x equals a times b to the x. Complete the equation for the function. Well, we can do this. We did this for exponential growth. And so what do we want? We want the initial value, which we know is 8. And then, we're talking about x this time. And then the growth or decay factor, either one can be found using our table method. So we are going to write our y-intercept in the table, and then our value 1 unit later, which is 2. The decay and the growth or decay factor is, both of them are y2 minus y1 over x2 minus x1. Okay, or you can just do y2 minus y1 because x2 minus x1 is just 1 minus 0. Now you don't worry about that right now. So it's going to be 2 over 8, which reduces to 1/4. So that means this function is 8 times 1/4 to the x. All right. So 8 times 1/4 to the x. All right, got it. Okay. My video is going slow, so I'm going to turn it off. Okay. Connecting exponential graphs with context. That is so important. This way we will know how these things actually exist in the real world. After a certain medicine is injected, its concentration in the bloodstream changes exponentially over time. The graph describes the medicine's concentration in milligrams per liter over time in hours concentration. So, with the word problems, we're always should be looking for the units, which are hours and milligrams. What was the concentration of the medicine? so concentration would be milligrams when it was injected. Okay, so the concentration of milligrams at the time of injection, which means 0 time had elapsed, looks to be 100. We will find out right now. All right, so they were asking us for the y-intercept. Let's do another one. Oh, the marriage, the celebrity marriage. On the day that a certain celebrity proposed marriage, 25 people know about it. That's the initial value. Each day afterward, the number of people triples. That's the growth factor. Which graph shows x? Oh, okay, x days afterwards. So y-intercept is 25. That could be A. It could not be B. It could be C. It could not be D. So it's right now it's between A or C. They both have a y-intercept of 25. Now, which one is tripling? That means one has to be 75 because triple 25 is 25 times 3 is 75. So is this 175? It looks like that is. Let's see about C. Now, you see C is only 150. That's doubling. All right, so make some interpretations for that. Have some fun. All right, and then do linear versus exponential growth from data. The number of burgers, milkshakes sold by a restaurant since it was open are represented by the following tables. Burgers, milkshakes. Determine whether the data described in the tables is best modeled by linear or exponential. Well, you could do this. All right, so we did this earlier. So we're just doing this in context. So reminder to you that we want always to have a constant difference in our x's, and we do. It looks like it's +3 each time. That's good. And then so we are just going to divide and that is the exponential test. And the linear test would be to subtract. And I'll just do 2 of them. It should be enough to do 2 of them. So I'll do the exponential test for the milkshakes as well. So 380 over 259, and then 501 over 380. We'll find out what that equals. And then we'll do the subtraction. 380 minus 259, and also 501 minus 380. Okay, so I'm going to do my division here. 691 divided by 353, 1.96. I'm rounding a little bit. 1034 divided by 691. 1.4, well, it's really like 1.5. Okay, 691 minus 353, 338. And then 1034 minus 641, 393. All right. So in terms of closeness, they both look kind of close, right? So maybe do another one, and let's try it. Let's do 1713 over 1374. 1713 over 1374. 1.2. Oh. So you see now I see it's decreasing. So I'm thinking this is linear, but let's also do the subtraction here. So 1713 minus 1374. 339. You see? So 339, 338, 393. So it's remaining around the 330s now. That did I do the math for that other one? Minus 6. Oh, 91, 343. Okay, yeah, so definitely linear. Okay, that exponential growth factor is decreasing with each time 1.9, 1.5, 1.2 is not remaining constant. Now, I would say this other one is probably exponential because the other one is linear, but I'm going to run the test. 1.32, 380 minus 259, 1.1, and 501 minus 380, 121. Oh man, hit the nail on the head with the linear. Okay, so I got linear for both. Did you get linear for both? All right. That was a lot of work, guys. That's okay. Now, this last one is rules of exponents, and this one was a struggle for a lot of people. So it's good that we're reviewing it. So exponents just mean multiply the same number by itself. 1, 2, 3, 4, 5, 6. So 7 to the 6. But that's not what this is saying. This is saying what other one is 7 to the 6. So here, when we have a fraction, we subtract the exponents. So that one works. And when we have multiplication, we add the exponents. And when we have parentheses like this, we multiply the exponents. 2 times 3. And here again, we have fraction, so we're going to do subtraction. Tricky, it makes your brain want to divide, but don't divide. All right, so it's A and C. So now here again, we have parentheses here. This is the power to power rule. We are going to multiply both of those exponents by the -3 outside of the parentheses. So that's going to be 3 to the -9 and 6 to the -18. But throw in the rule of negative exponents. Negative exponents can also be written in the denominator as a positive exponent and vice versa. If you have, vice versa, you can write a negative exponent in the numerator as a positive. So this would be an answer if I saw it, but this is also because it's the same expression with positive exponents, and we can do that as long as you write them in the denominator. Okay, did Chris make a mistake? If so, I hope he didn't make a mistake, but maybe he did. Okay, he's supposed to multiply the exponents. So do we see 4 to the -8? What? Oh, well, I guess you can add them inside parentheses too, can't you? But -2 plus -3 is -5. So that works. Then you're supposed to multiply. So this is always one that I get confused. Step 2, that's where the mistake is. All right. Because it's supposed to be 4 to the -15. Okay, so here we cannot subtract the exponents. Do you know why? The reason why is because the bases in the numerator, the base is b. In the denominator, the base is 4. The bases are not the same. And so we cannot combine those two terms. But what we can do is we can multiply both of their exponents by -3. All right, so that's going to give us b to the -21st over 4 to the -15. And then, like I said, we could rewrite it as 4 to the +15th over b to the +21st, the old switcheroo. or we could even just switch one of them, 4 to the negative 15th b to the positive 21st. Or we could even keep the b to the negative 21st and write 4 to the positive 15th on the top. So what do we have? Do you have any of those? 4 to the 15th, b to the positive. That's the one. Last question. Okay, so this time the bases are both 5. And so we can subtract those exponents. 5 to the 2 minus 8 is negative 6, which is the same as 1 over 5 to the positive 6. And that is that choice. And oh no, there's 2 answers. You guys didn't tell me that. Well, 1 over 5 to the positive 6 is the same as 5 to the negative 6, and that is right here. 2 times negative 3 would be negative 6. Got it. All right. Have a great time posting the organizer ones for each assignment. Don't post in the green unless you get 100% on that assignment.